Welcome! This is my first video that tries to describe the state of the climate for a particular month, in this case April 2011. I'm sure there's going to be a lot of things that I'm going to need to iron out, but any useful suggestions on how to improve the video would be greatly welcomed. There is a great deal of nonsense talked about the climate, both on TV and on the web, most often by people with no qualifications to do so. This is an attempt to sort out some of the chaff from the wheat. The most common mistake is to confuse local weather with global climate. So what is the difference? What is happening on a given date at a given time in a given area is weather. But comparing that to the average conditions that have been established over a much larger area or a much longer time is climate. So in effect, climate is average weather. So where do we get the information? Primarily it's from ground stations, some of which are shown here. But the ground stations are not the only source of data. We have data from buoys out at sea, ships, aeroplanes, and most importantly from satellites that view the globe regularly every few hours. The data is primarily reduced by 3 organisations, although a lot of other international organisations do their own studies as well. The primary 3 are the NOAA Climate Data Centre, the NASA GISS Institution in Columbia University, and the Met Office in the UK. For the purposes of this video I'm going to use the NOAA data because NOAA is the primary organisation in the US for collecting and archiving climate data. So let's first take a look at the temperature. Here's a map of the temperature anomaly for April 2011. There are a couple of things to note with respect to this map. First of all, we must understand the colour scale. Red dots mean that the temperature for that area is above average. The larger the dot, the more above average it is. Similarly, the blue dots mean that temperature is below average. Again, the larger the dot, the more below average it is. The second thing is the dates over which the average is calculated, 1971 to 2000. That range contains about 30 years of global warming already. So, if we were to say calculate the same graph with respect to a 20th century average, the red dots would all be much larger and there'd be fewer and smaller blue dots. Lastly, the thing to note is the blue triangle in the eastern Pacific, stretching from the middle of the South American coast up to about Baja. This is the classic signature of La Niña, a cooling of the Pacific. And for about the last 9 months we've had a very extreme example of La Niña, although it is now moderating, which has interesting consequences for 2010. 2010 was rated the hottest year on record, tied with 2005. Imagine how much it would have broken the record by if there hadn't been this large La Niña, or it would have been even hotter if we'd had a large El Niño. So let's put all that speculation aside for the moment and just take a look at the graph as it is. Do you on balance see more red than blue, or more blue than red? If your answer is red, I would agree with you. That would mean April of 2011 would be significantly warmer than the Aprils of the last 30 years, implying indeed that global warming is occurring. Let's take a look at these results graphically. Here are 3 plots. The bottom one represents the average land temperature for April since 1880 to the current day. The land temperature was 1.1 degrees centigrade above the 20th century average, which would make it the 6th warmest April on record. Above that are the ocean temperatures, but as we would expect with the La Niña, those are a little bit cooler. It was only 0.4 degrees centigrade above the 20th century average, and that made it only the 11th warmest April on record. When you combine the two to get a global temperature, which is the top plot, when you combine the land and the ocean temperatures you get the global anomaly, and that turns out to be the 7th warmest on record. The amazing statistic here is that makes it 35 years in a row that April has been above the 20th century average. There is a 34 billion to 1 chance of that occurring accidentally. Another diagnostic of the climate is the snow and ice cover. In this first plot we show the snow and ice cover for the Northern Hemisphere for April the last 45 years. You'll note that 2011 is well below the average, and it has been that way in April for the last 8 years consecutively. Similarly, the sea ice is below average. In this particular case, 6 million square kilometres below average. Now that's the Arctic sea ice. How about the Antarctic? Well, I'm afraid that's not much better. It too is below average, by about 8 million square kilometres. For those that think the US is immune from this, think again. Remember the huge outbreak of storms on the 4th of April? One of the largest outbreaks of storms in US history. It stretched from Louisiana up through the mid-Atlantic states, and from northern Florida to Ohio. If we look at the average departure from normal for each of the areas in the US, we can determine whether the lower 48 were above or below average temperatures. Red here indicates above average temperature and blue below average temperature. Do you see more red than blue? If so, then the US is suffering from a bad case of global warming. Another interesting plot that NOAA provides is a comparison of the areas in the US that have very, very warm temperatures compared with those that have very, very cold temperatures. Again, red indicates above average, blue indicates below average. So here again, do you see more red or do you see more blue? By now I think you know the implications of your conclusion. I think one of the more interesting plots is this one, which compares the number of record highs with the number of record lows for each decade. If there was nothing much going on with the climate, then these numbers should be approximately equal. However, in the last decade, 2000-2009, there have been twice as many record highs as there have been record lows. You see, global warming doesn't mean that there will be no record lows, because the variation from day to day, week to week and year to year is much larger than the trend in global warming. It would take many decades for it to reach the point where the global warming trend would overcome the high-low range of temperatures. Anyway, a special thanks to NOAA for the information that I've shown here today. If you want to see some more of my global warming videos, they're listed in the description box below. Go to my channel if you want to see some of my Sun Today videos, which I hope you would find interesting. So that's it for today. Keep safe. Bye for now.